and welcome my dear students. So in this lecture series I am going to solve some of the interesting and challenging numerical problems from the physics book Pathfinder. So let us start with the session that in this situation there is a cord of length L is attached to a nail driven into the curved surface of a cylinder. So there is a cylinder. So now with the cylinder with a nail fixed at this position, so a cord is being suspended and there is a ball B. So cylinder having a radius of r is given. The cylinder is fixed with its axis. Small ball B of mass m is hanging at the lower end, and you are asked to calculate what is the range of u on this ball B, so that the cord will certainly slack during the subsequent motion. So this is the situation where the particle is performing a vertical circular motion, and we know that for a vertical circular motion, see if I say this is a vertical circle performed with a particle with a velocity u. So if I project the particle with a velocity of root 2 gr, then it goes up to this point, A point. If I project the particle with a velocity of root of 5 gr, then it go up to B point. So any velocity which lies in this region, so that means the particle will, or the tension in the string will be 0. So for this, u should be in between root of 5 gr to root of 2 gr. So this is the range of u that we should know. Okay. Now we have to apply these points. Now what is the difference between these two problems? So here the point O is not fixed. Point O is not fixed. Why? Because the wire is wrapped around the cylinder. So initially, once I throw this ball, then the length of the string is L. Now since point O is changing, so that means the radius of the vertical circle is going to change. Okay. When the particle comes to point A, so corresponding to this figure A, that means the string has to move by this much distance. So this is the portion of the string that is being wrapped inside the cylinder. So now this is the portion of the point B, the ball B. Now at this position, what is the radius of the circle? This is the radius of the circle. Okay, that should be how much? L minus pi r by 2. Why? Because pi r by 2 is the length of this portion of the string that has been already wrapped around the cylinder. So this is the corresponding A point in the vertical circle. Similarly, if I move it further, then the particle will come to this position. So let us say this is the position where this much portion of the another thread is being attached to this. Okay. Now the ball will be over this position. So this is the point B. So at this position, what is the length or what is the radius of this circle? So that radius of the circle is now L minus pi. L minus pi. Okay. So in this vertical circle, every time the radius of the circle remains r. So at each and every point, the radius of the circle is r. But once I wrap the string around the cylinder, now the radius is going to change. That is the main consideration you have to apply over here. Now, so I want to calculate the velocity at point A. So in order to move the particle up to point A, so gaining potential energy from this point to this point, let us say this is the change in height. So what is this potential energy gain? That is equals to mg into L minus r. Why? Because this is the r distance. Okay. So gaining potential energy, that should be equals to mg into L minus r, and that should be equals to our initial kinetic energy. So that should be equals to half m v1 square. Let us say v1 is the velocity that you have to impart on the ball so that you reach just up to point A. Okay. So corresponding to that, I can calculate the v1 number should be equals to root of 2g into L minus r. 2g into L minus r. So that is the first answer where v1 is this much. Now if I go up to point B prime, let us say this is the B prime point. Now once I throw the ball, so at point B prime, radius of circle is this one. So at this point, so let us say here the condition is that t should be equals to 0. So that I can calculate the velocity v prime over here. So if I do this calculation at point B prime, so if I say this is the point B prime, where the velocity, let us say v prime. Okay. And radius of the circle is equals to L minus pi r. L minus pi r. Okay. So at this situation, if I take the tension inside the string is T and that is equal to 0, and mg is acting downward. and in this direction centrifugal force, that is M V prime square by R is L minus pi R. Okay, so corresponding to that, what you can write that V prime square should be equals to our G into L minus pi R. G into L minus pi R. So that is the velocity at point V prime. So this is the velocity. So corresponding to this velocity, now, so in order to attain that much velocity, let us say this is the point B prime, this is the point B prime, which is at a distance of this much distance is L minus pi R. This distance is L minus pi R plus from the ground reference frame, this is the point which is at a distance of L. Okay, here I am projecting the particle with the velocity of U. And it goes up to point B prime. It goes up to point B prime. So gain in potential energy is how much? Gain in potential energy is equals to mg into L plus L minus pi R. That is the gain in potential energy. And that should be equals to loss in kinetic energy. So what is that loss? That loss is equals to our half m into, let us say, at this situation, the particle is projected with a velocity v2. Where we project the particle with the velocity v2. So half m v2 square minus half m v prime square. So half m v prime square, and v prime square is how much? G into L minus pi R. Okay. So solution of this will be the value of v2. So once I simplify this, so I can get the v2 number as equals to root of 5gl minus 3 pi r into g. Okay. So that means this is the velocity that you have to impart so that the particle will go up to B prime. Similarly, first we calculate the velocity of V1 so that the particle will go up to point A. So this is corresponding to our number 2g into L minus R. So any velocity which lies in between these two range. So that means that now the string will be slack. That means the particle will be between A and B prime, like this way. Okay. So answer for this situation will be the velocity should be in this region, that is 2g into L minus R less or equals to V less or equals to 5gl minus 3 pi rg. Okay. So if I project the particle within this particular range, then only the string becomes slack. Hope you understand this. Thanks for watching the video. If you like it, please subscribe my channel.